What if I told you the spacecraft, sent to save a dying satellite, is now the one desperately clinging to survival? Welcome to the twisted reality of the Link rescue mission, a story of ambition, engineering brinkmanship, and the cosmic equivalent of trying to fix a toaster mid-freefall. Let me break this down. Here's the setup. NASA's Swift telescope, a $250 million, 20-year-old workhorse that maps gamma-ray bursts, is slowly plunging toward Earth. No thrusters, no propulsion, just waiting for atmospheric drag to tear it apart. Enter Link, a fridge-sized robot from Arizona-based Katalyst Space Technologies, designed to grab Swift and boost it to safety. Bold? Absolutely. But here's the kicker, Link is now spinning out of control, 2 of its stabilizers are dead, and time is burning away faster than Swift's decaying orbit. Let's unpack the irony. The rescuer needing rescue. Classic space opera. But what makes this fascinating isn't just the drama, it's the physics nightmare. Imagine trying to stabilize a spinning object in 0G with only one functioning thruster. The engineers aren't just fixing a satellite, they are improvising a solution to a problem they probably never trained for. And remember, this isn't some government super project, it's a private company racing against orbital mechanics. That $30 million NASA-paid Katalyst sounds less like a fee and more like a high-stakes poker bet. Now, why does Swift even matter? Sure, gamma-ray bursts are cool cosmic explosions, but here's what people miss. Swift's data helps us map the universe's most violent events, which in turn tells us how galaxies form and die. Losing it isn't just a financial hit, it's a gap in our cosmic timeline. And October's the cliffhanger date. That's not arbitrary. At 300 kilometers altitude, atmospheric drag becomes a runaway train. Once Swift hits that point, even Link's robotic arms couldn't save it. So, the clock's ticking, but this isn't a Hollywood countdown, it's a messy, technical grind. What's really intriguing here is the bigger picture. Private companies handling orbital rescue missions. That's new. Traditionally, this would have been a NASA-only job. Now, we are outsourcing life support for satellites to startups. Is this genius or a recipe for disaster? Think about it, if Katalyst pulls this off, it'll be a blueprint for extending satellite lifespans. But if they fail, it'll be a cautionary tale about privatizing high-risk space ops. And let's not gloss over the engineering hustle. Slowing a spacecraft's spin from 9 degrees per second to 1.47 with just thruster burns. That's like stopping a tornado with a hairdryer, but in space, where every action has an equal and opposite reaction. The software updates they are uploading now. That's not just code, it's a Hail Mary pass to reprogram stability on the fly. This isn't just about saving Swift anymore. It's about proving that commercial space rescue isn't just a buzzword. So here's my closing thought, even if Link fails, does that make this mission a failure? I'd argue no. The fact that we've gotten this far, private spacecraft chasing orbital rescues, engineers battling physics in real time, shows how far space tech has come. But if they do pull it off, we are looking at the start of a whole new era in orbital mechanics and satellite economics. What do you think? Was this worth the gamble? Drop your thoughts below, and don't forget to smash that subscribe button if you want more deep dives into the wild world of space drama.